There are three inputs and one single output, right? So how can we draw the truth table? If there are three inputs, we know 2 to the power 3. Number of input combinations could be classified, which is 8, right? 2 to the power 3 number of input combinations are there, which is 8. So it's like you can get input combinations, right? If I share you the whiteboard. The whiteboard is taking some time to load. Right. I think the whiteboard is visible to you guys, right? Can you even give a react at least?
Visible.
Visible. Okay. So there are three input combinations, which is A, B, and C. And the output is Z. So we can draw the input combinations like, okay, I will draw it like this. Have A, B, and C. So it's 0, 0, 0, the first input combination. If there are three inputs, there are 8 input combinations. This is 0, 0, 0, 1, 0. I think you guys know this, right? 0, 1, 0, 0, 1, 1. Then you have 1, 0, 0. Then you have 1, 1,
Zero.
0, and 1, 1, 1. Right? You okay with this? Are you okay with this?
Yeah.
Okay. So then what's our diagram about? My God, I have to remove this. You can see it from your mobile or phone or something, right? The diagram. I mean, the question paper, because I can't like share both of them together. Can you?
I can't see it.
Or you can't see it. Okay, then I will share it. Okay, so this is the answer paper. Then we will do the question here itself. We have A, we have B, and we have C. We have 0, 0, 0. I will write it real fast. 0, 0, 1, and 0, 1, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1. Then you have 1, 1, 0, and 1, 1, 1. So then A comes, and here you have A, and again you have B here. It goes through what type of gate? What do we call this type of gates?
AND gate.
This is not AND gate.
Not.
No, this is a OR gate, right? This is AND gate. NOT gate is something like this.
I like arrow. Yeah.
Yeah. So this is a OR gate. This become A, O, B. The similar type of gate is here. So what does this becomes? B, O, what?
C.
C. And C comes here. Then C goes here. So it's go through a AND gate. So it's A, plus, AOB dot BOC and C, right? Okay. So then we have A plus B. We take this also as input. We'll take it also as input. Then you have B plus C. I don't have enough space here. That's the issue. And then you have the output. Okay. Shape. So A plus B, 0, 0. A plus B means AOB. In AOB, in order to get the input as 1, what should be the two input combinations? In OR gate, if it is 0 and 0, then the output is 0. If it is 0 and 1, the output is 1. If it is 1 and 0, output is what?
1.
1. Output is 1. If it is 1 and 1,
It's 1.
it's 1. So here A, O, B, so 0 and 0, the output becomes
0.
0. 0 and 0, the output becomes 0.
0.
0 and 1, output is 1.
1.
0 and 1, the output is 1. 1 and 0, the output is 1. 1 and 0, the output is 1. 1 and 1, the output is 1. And 1 and 1, the output is 1. Okay? You are clear with it?
Yeah.
Yeah. Okay, then you have B, O, C. 0 and 0, the output is
0.
0 and 1, 1.
Output is
1, 1. Here,
0.
0, 1,
1.
1,
1.
1. Right. Then you have the final output. Final output is the AND operation of these three. These three. AND operation is the final output. So in AND operation, if it is 0 and 0 in AND, output is?
Opposite.
Huh? Output
Opposite.
is 0 and gate. If it goes to AND gate, that's not gate. The opposite comes and is the not gate. If 0 and 1, the output is 0 here. 1 and 0, 0 in AND gate. I'm talking about AND gate, right?
Okay.
AND gate. 1 and 1, the output becomes 1. Only in the situation where both the input is 1, the output becomes 1 in AND gate, right? Okay, so then here 0, 0, 0, it's 0. 1, 0, 1,
0.
0. 0, 0, 0, 1, 1,
0.
0. 1, 1, 1, 1.
1.
1. Then 0, 1, 0,
0.
0. 1, 1, 1, 1,
1.
1. 0, 1, 1, 0.
0.
And finally 1, 1, 1, 1. So your output should be this.
Yes.
Did you get that as the
Yeah.
output? Okay.
Yeah.
Then let's go to the next question. Have you done the next one?
No.
Okay. Then shall I give you like 3 minutes to do it?
Right. Okay.
Right. The question is, I will read the question. Using a K map, Kano map, derive the simplified sum of products, SOP expression from the Z, which means the output. I have the output here in the screen. You can look at it and do the question. 3 minutes.
Excuse me. Hello. Excuse me. Excuse me. Hello. Hello.
Sorry, I was muted. Are you done?
No, teacher. If you don't mind, can you explain me once? Because I haven't done this chapter.
Okay, yeah, I will. Oh, sorry, I was muted, right?
Yeah.
Okay. So, I was telling like here it was 0, 0. Here only one bit change, right? That's why we don't write it as 0. Normally we write it as 0, 0, 0, 1, 1, 0, 1, 1. Right? You can hear me, right?
Yeah, I can hear you.
Yeah. So, but in this context, we are only writing 0, 0, 0, 1, 1, 1, 1, 0 because only one bit change here, right?
Yeah.
Okay. If here, if it is 0, 0, the last bit change. It becomes 1. The last
Why
bit
it
change.
becomes? Why it changes?
Because there is a specific rule that only one bit could change when the sequence is changing.
Right. Okay.
So if it is 0 and 1, only one bit change. The first one changed to 1 and the second one remains the same. Right?
Okay.
That's
Yeah.
why we change these two. If it is 1, 0 here, then 2 bits has changed. The 0 has changed to 1 and 1 has changed to 0, right? That
Yeah.
won't happen. That is the reason which we take what 1 1 here and 1 0 here, and then again one bit change. One first one is 1 and the last one becomes 0, right?
Okay.
Okay. So then in the C part we write 0 and 1. Okay.
Yeah.
Then we draw this net like this. And then what we need to do is we need to fill this we need to fill the ones which are ones. First, we need to fill the ones in the Carnot map. So here, 1 came here. So the as I can remember, the input combination here was A0, B1 and C1. So A was 0, where 1 came. A was 0, B was 1, and C was 1. I think you have written in your papers also. Am I correct?
I took a screenshot of it.
Ah, okay. Is it correct? The first one input, the input combinations was this, right?
Wait. Yeah.
Yeah. So second one was Second one was A was 1. B was, I think, 0, right? And C was 1. Am I correct?
Wait. I didn't understand this part.
I mean, which the in the truth table where we
Yeah.
got 1, what are the input? What are the values for A, B, and C in that specific truth table?
Uh,
In the line we got 1 here.
in C, we have got second place.
Yeah. So in the third place we got a 1 right in the truth table.
In third place, we got A for 1.
No, I mean the fourth place.
Yeah, it's 1 for A.
1 for A.
And 1 for B. And 0 for C.
1 for A.
1 for B and 0 for C.
Oh, isn't it 0? Because
No, it's 1.
it's 1. Are you sure?
Yeah.
You sure? Shall we do it? Shall I do it? So it was 0, 0, 0, 1, 0, 1, 0, 1. This is 0, 0, 0, 0. So the first place we are getting a 1 is the fourth place, right? So
Yeah.
it's here, not here, not here. It's this place. So it's 0 for A, B 1, C 1. Right? Can you see?
Yeah. Yeah. Why
Yeah.
we are taking fourth place?
Because that's the place we got 1, right?
Yeah.
Okay. You
Yeah.
got it.
Yeah.
Okay. Then the next place we got 1 is 1, 0, 0, 1. Here. 1, 0, 1.
1. Yeah.
101, A 1, B 0, and C 1. And the last place is 111. So, okay. So then it's 1, 1. C is also 1. Right? So here we have to mark these places which comes 1. So A becomes 0. Then B becomes 1 and C becomes 1. What's the place in this Kano map?
Third one.
Third one is. Am I correct? This is the place, right? A is 0, B is 1, and C is 1.
1. Yeah.
Yeah. Then we have A is 1, B is 0, A is 1, B is 0. Okay, it's here.
And C
And
is 1.
C is 1.
The
It's
last.
here.
Yeah.
And then you have 1, 1, 1, 1, 1, 1. Remember to name the other places with 0. In the other places, you must insert zeros. That is a must, right? They check it in the exam, right?
Okay.
So then you have to do grouping. In Kano map grouping, you can only group as 2, 4, 8, 16, like 2 to the powers, right?
Okay.
Okay. So here, and as one specific group should only have, should at least have one element to that specific group,
Yeah.
right? If I take this as a group, right? And this, imagine, no, imagine something like this. Oh, sorry. Imagine something like this, right? So,
Okay.
if I have this in the corner map, what I can do is I can group it by this. One specific group. This is one specific group, right? One specific group means some this cage or something, right?
Yeah.
This rectangle should have at least one. This rectangle has this one, which is only for that. And this rectangle has this one, which is only for that. And this is common to both. That's fine, right? So how can you group this?
We can't group these three together because
Yeah,
that's not
we
good.
can't group these three together. So what can we do?
First, we can group this
Two.
two.
We can group these two, and then we can group these two.
Yeah.
Right. Okay. After that, they ask us to write the SOP output expression. They are asking us the expression.
That's all good. Huh?
So how can we write the expression? We can write the expression like so. In SOP, if it is 0, we call it A. If we take the element as A, it's A bar. Right?
Yeah.
If it is 1, it's A. Right?
Yeah.
So
Yeah.
how can we do this? So it's you have, if we take this element, how can we name it? We have A, which is A bar. We have B, and then we have what?
C.
C. Then we have A, then we have B, and then we have C. Then we have A, then what do we have? A,
B.
B, B bar, and then we have
C.
what?
C.
C.
No.
C.
It's
C. So, okay. So we have these three, right?
yeah.
Okay. Oh, so how can we settle this out to a single expression? We can take first this group. In this group, we have A bar, B, and C.
Yeah.
And A,
B and C.
B, and C. So we can take the common things out of this is A bar and A. So these two are cancelled. A bar and A, 0 and 1. Imagine it's like 0 and 1. So 0 and 1 cancel. So
Cancel.
what is the output? B and C.
Yeah.
Right? Then we have the next group. Next group is A, B, C. And A, B bar,
And C.
C. So what is the output here?
Uh, A and C.
It's A and C. Right?
Yeah.
So
Yeah.
these two are combined by what? We say uh, these two are combined by a OR gate, no? Which means this in SOP means sum of products. Sum means this, right? Products means the multiplication, right? In
Yeah.
SOP, we take this as products. These are products, no? Even though we don't
Yeah.
have the dot or the multiplication here, it's a product. In
Yeah.
SOP means sum of products. So we can take the sum of these two products, which is AC plus BC,
B.
right? Did you
Why can't we?
understand? Yeah.
Okay.
Are you clear? I
Yeah.
think you had a question.
No, I asked. You didn't write C before, no? So I asked, why didn't you write the C?
C?
Yeah, now you have written it.
Ah, okay. I didn't understand. Where didn't I write C?
Now you have put AC plus BC.
A.
In A, the C was written late. I think the coverage problem.
Ah, okay, okay, okay. Right. So there is no issue in this, right?
Yeah, okay.
Okay. So with that knowledge, can you do the POS one? In POS, you have to mark not once, you have to mark zeros first, right?
Okay.
Same as it's the same format as this Kano map. Oh my God, what happened? Um, right. So then, yeah, in POS, first mark. I mean, you have to mark zeros and ones, and you have to group zeros, right?
Okay. Yeah.
You have to group zeros, not ones. I meant that. Okay, I will give you 5 minutes. Just do
Okay.
it fast. Okay. So in the beginning of the class, I was telling that I will continue the lesson until 8, from 6:30 to 8 today. And
Yeah.
because I'm outstation today, and because some join late, and I will do the rest in the other class. Next, may the few 30 minutes we are missing, we will catch up in the other class.
Okay. Excuse me, miss.
Yeah.
I'm done with the grouping. Can you tell me now what should I do?
Okay. So yeah, if you are done, you can let me know. What's your output?
0 0 0 0 0 1 1 1.
You got the output as the same thing, right? It's
Yeah.
0, 0, 0, 0, 0, 1,
One,
1,
one,
1. Okay,
and that
how did you group?
the 4 zeros together and other 2 zeros together.
Very good. Okay. After you have grouped like this is product of sums. Product of sums, which means there is an addition. Within the addition, there is multiplication. This means product of sums. Additions are combined by multiplications, right? So the first is, so in this context, we took, in POS, we took this as A. If it is 0, we took it A bar. No, here we take
Yeah.
A, right? If it is 1, we take it as A bar, right?
Yeah.
Okay. So the first one, how can we write it? Product of sum. We can write it like A because A is 0, B is 0, and C, this should be addition, sums, okay,
Okay.
and not like SOP. And here it's also C is also 0. No? So then you have A plus, B is what? 1, which means B bar. The C is,
How you say B is 1?
because here you have 1. 1
Right.
means B bar.
B bar. Yeah. Okay.
And C is it's 0. So can you write the
0.
others as well and do the calculations, which you need to take the common values and take the product of that values and give me the answer.
Okay.
Okay. Yeah. Just quickly do it in 5 minutes.
Okay.
Thank you.
I'm done. Hello.
Okay. Okay. So what's your answer? Can you put it in the chat? Everybody who has completed, just drop the answers to the chat.
Okay.
How did you get the answer? Right? Here it becomes A bar, B plus B bar plus C. Then it's A plus A bar plus B. A bar plus B, right? B plus C. So the output of this is only C is common. So it's C. And this is A plus B plus C and A plus B and C has 1, which means C bar. So it's A bar, A plus B. So the output would be A plus B dot C, the product of sums. Right. Okay, are you clear with this?
Yeah, clear.
Okay. The next question is of the two expressions, so SOP and POS, you obtain in B and C above, which one is better to implement? Which one is better to implement a more simplified logic circuit than the given logic circuit above? Explain your answer. What is easier? So the first output we got is A C plus B C. We got A plus B dot C. Right? Okay. So what would be the easiest?
The POS expression.
The POS?
Yeah.
Yeah. Why?
Because there are less number of logic circuits used.
Yeah, you're correct. If you implement SOP, you have to use here a AND gate, again a OR gate, and again a AND gate. Here, but only a OR gate and AND gate. Right? So POS is easier than the SOP. Okay. Are you clear with the logic gates question?
Yes.
You're thoroughly clear. Okay. Then we are moving to the next question. The network question. Okay, shall I give you 10 minutes just to complete the question? Because I'm doing this because I know you guys won't do this at home if I tell you to do the paper and come. But if I give you time during the class, so then I know you guys would do the question. And then we can mark the answers. No use of like I writing, I giving the answers, right? Continuously. So first, you guys must try, then I can explain it with the theory, right? So, have you done this before? I mean, have you done this today?
No.
No. Okay, shall I give you 10 minutes so that you can complete it?
Yeah, sure.
Yeah, okay. Then we'll start at 7:30. It's 7:19:20, no? Yeah, okay. Complete it. Are you done? Hello?
Yeah.
You're done. Okay. Consider the following scenario. The QR company has three departments, namely finance, marketing, and human resource. At least all the activities of the PQR company are conducted manually. The company decided to customize all the activities by establishing an IT unit with a computer lab for staff training. Resources will be allocated for each department and the IT unit as follows. A company proposed the following: a local area network. So this is the department. So let's go to the question. Which network topology is the most suitable to satisfy all the mentioned requirements? So the company proposed a local area network for each department unit in order to share a specific software or source. Okay. A local area network for each IT unit. LAN in each department to be interconnected via a unit. LANs should be interconnected. These LANs, they have specific LANs, and these LANs should be interconnected. All computers to be given efficient internet connectivity with the help of a DNS, okay, and a proxy server. An internet service provider to supply the internet connection to IT units, the entire network to be protected through a firewall. Okay. Which network topology is the most suitable to satisfy all the above mentioned requirements? Give one reason to justify your answer. What do you think?
Hard topology,
Stop. Why?
because it has a central node which is interconnected to the
And
IT
there's a
unit.
thing that these things are interconnected to a central thing, right?
Yeah.
Even the LANs should be interconnected to the IT unit. So that's why in a star topology, what do we have? We have a central switch and all the devices are interconnected. So the most suitable would be a star topology. Great. Then the next question is, the network administrator have received this IP address block. Okay. Okay. So we have to divide this into four subnets. So how can we divide this into four subnets? It's 2, 7, right? So when we are dividing into four subnets, first what we can do is we can write this, we can take the last subnet. We have 8, 8 bits in one octet. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, and 8. Right? So we have to divide this into four subnets. Four subnet means how many bits should be taken? So,
156.
huh? How much?
256.
So, we need to take some bits to the network part, right? So, if we divide this into four subnets, so 4 means we need 2 to the power 4 is 2 to the power 2 is 4. So we can take how many bits? 2 bits. 2 bits are needed. Right? We take the bits from here, from the first side. So we take 2 bits. This becomes 1 and these are again 0. First, in the first instance, these all are zeros. And as we take 2 bits, these first 2 becomes 1 and all others become 0, right?
Yes.
Okay. So, first we can to write the subnet mask. Subnet mask means we are taking the calculation of all the things. So, there are 3 octets, 4 octets like this. No? So, the first 3 octets are filled with ones. This is a VLSN, which means variable length. No? So, the first 3 octets are complete with 1. We have, so or the combination of all these things are 255 dot 255 dot 255. But the last octet, only the first two bits are 1. So what is it? This is 128 and this is
128 plus
64. 128 plus 64 is how much?
192.
192. So the subnet mass will be 192. Simple as that. You can complete. Right? Then we need to take the block size, which means the block size, right? So there is an equation for the block size. Block size equation is block size equal block size equal 256 minus last octet, the last octet of the subnet mass, last octet of the subnet mass, the last octet in the subnet mask, right? Okay. So what is the last octet of this subnet mask?
192.
192. So we can write 256. We can subtract 192. Subtract it quickly and then
64.
64. So the block size becomes 64, right? Okay. So the range, how can be the range? The first range is given is from 0 to 63. So the second range would be usable IP. This is the network address and this is the broadcast address. You know the difference between the network address and the broadcast address, right? What is a network address?
This is the one with
Network address is the address we use to identify the network, right? And what is broadcast address? Broadcast address is the address we used to send all the like broadcast. We used to send for all the devices in the network. Broadcast into all the devices in the network, right? Okay. And the usable IP range is from so we can't use the network address. We can use the broadcast address. So between that, from 1 to 62 is the usable IP range. So what is the network address here? It's 64 here. Then it's starting from 63 here. It's 64. So the block size means from 0 to 63, there are how many? 64 IP address now. So that is the block size. If we calculate from 0, we are not calculating from 1, we are calculating from 0. So 0 to 63, there are 64 blocks, network addresses, right? Addresses.
Yeah.
From 64 to 128, no, it's 127. And the range is from 65 to 126. It's from 128 to 191. So it's from 1 to 9 to 190, right?
Yeah.
And then you have 192 to 255. 255, which means it's from 193 to 25, right? Yeah. Did you get the same answers as this?
Yeah.
Any doubts? Huh?
No, clear.
No clear. Okay. Then shall we go to the next question? I think showing the current topology and devices, draw a logical arrangement for the company. They are asking us to draw what? A network diagram. Right? A network diagram. So shall I use the whiteboard for that because there won't be sufficient space here. Have you drawn the network diagram?
Yeah.
Yeah. Is the whiteboard visible?
It's loading.
No, it's still loading.
Yeah. And now it's ready.
Yeah. Okay. So it says we have like three. We have three. What? Four, right? Four institutions. So first of all, you need to know that all these things are coming from internet. Internet means the cloud. Internet. Internet. Right? So internet, to access internet, we should have a router. From the router, it comes through a firewall, right? It comes through a firewall.
Can you draw the firewall before the router? Will it be wrong?
No, yeah, it is wrong. Because first you have to have the connection and then the you can, no? Yeah,
Oh,
yeah, you can. Sorry. Then it has said that we have to connect it to the IT department, right?
yes.
Yeah. So you can write the IT department switch. Switch of the IT department. Right? So there are around switch of the IT department have 50. So you can write one, the first PC, and then some dots, and the 50th one. Right? And the IT department contain a printer, which is not a network printer. Network printer is something attached to the network itself. You can connect it here. But this, you have to connect it to a device. This is not just a printer, right? And then you have a DNS server. All these DNS servers and everything are also connected to this. And the proxy server, right? And you have a LMS, right? So through that, so these cables, these cables we use here, we use normally fiber optic cables, right? Fiber optic cables are connected here. But in the LAN itself, we use twisted pair cables, right? Okay. Then these cables are connected to three other departments. Uh, we have a marketing department. We have a finance department. And then we have a HR department, right? So we connect devices to this. So we have 40 printers. You can just write the first printer and keep some dots and write the 40th printer. That would be totally fine, right? And then you have a network print. It's devices. And then you have a network printer which is connected. In a network printer, we can connect the network printer into the network itself, right?
Yeah.
And then you have the software systems. You can draw this. I think you got a clear understanding of the system. Do I need to draw it? You can continue with, right?
Yes.
Yeah,
I've drawn.
you have drawn it. Okay, then let's go to the next question. Next question is Lama. Network administrator decided to dynamically manage the IP addresses of the entire network. Write down the mechanism that need to be required to achieve this task. Dynamically allocate IP addresses. What is that?
I can't answer this question. I don't know.
You don't know.
Is
It comes in the network theory part. So
it
you
what
have several servers. Yeah,
server?
yeah. I can't hear you properly.
Like, will the answer be as connecting a DHCP server or something?
Yeah. So it's in the network theory part. You have to study it. There are a lot. You have proxy servers, DNS servers, the users of it, and the users of the functions of them. And you have some network connection. You have dial-up connection, and network theory part is something huge. And you get questions for those in the MCQs and even the structure paper, right? So you have to study, and while we are doing the question papers, we would be able to catch some of those, which is in the network theory part. So here the answer is the DHCP server. DHCP server is what we use to dynamically allocate addresses, which means it's something like this. If I draw it to you and show, when the theory is something like this. So the dynamically manage the IP addresses. So each means, so DHCP, if you attach a DHCP server, DHCP server gives dynamically IP addresses to these devices in the LAN. That is the responsibility of the DHCP server, right? So the router you have it at your home, it has all these DHCP, DNS, proxy, everything. Sometimes even inbuilt firewalls are also attached to the router, right? Okay. So while we are going through the papers, you would be able to catch them up. Right. Okay. We have only like 10 minutes. So let's move to the 7th question. We'll try to complete it. But if
I haven't studied this theory yet. Like,
really? Okay. So shall we push it to the next week, because I am also in a hurry today. I'm outstation, and yeah. It's because even the number of people in the class is less. I think it's because of this out of the season. And shall we meet on the next day then?
Sure. Thank you
Okay.
so much.
Thank you. Yeah, okay. So the next class will be on next Wednesday from 7:30. Thank you. Bye. Good night.
Good night. Thank you. Have a nice day.
Okay.